Hello, collegiate scholars. I hope this year has gotten off to a great start for you. Today we are going to discuss the angle addition postulate. It's kind of like the segment addition postulate, except we're dealing with angles. But before we get into it, we're going to discuss classifying angles and identifying angle pair relationships. I hope you're ready for a great lesson. Let's get started. So let's start by defining an angle. An angle is a figure formed by two or more rays, which we'll call sides, with a common endpoint that we call the vertex. So for this angle, we have ray RS, ray RT. These are the sides of the angle. Now those sides of the angle meet at point R, we call the vertex. So we call this area the interior of the angle, and on the outside, we call that the exterior. Interior means inside, exterior means outside. Now just like we can name these rays, or we could name a line or a plane, we can also name the angle. We'll name the angle by the points here. We'll notate it with this angle side, and we'll name it angle SRT, or we can name it angle TRS. The order doesn't matter how we write the letters, but what is important is that you write the vertex in the middle. You should just be able to read the name of the angle and know what the vertex is. It's the point in the middle, which in this case is R. We could also name it angle 1 because it has that 1 labeled there at the vertex. The unit for the measure of an angle is degrees. Not like temperature, but we're actually talking about a part of a circle. So you'll often see an arc on the interior of an angle to represent how much the measure is. I'm just going to guess that this is about a, 45 degree angle. So if I continue that arc around the interior, that makes a complete circle. And you may know that a whole circle is 360 degrees. So basically, angles are a part of a circle. Let's discuss some pairs of angles. We'll start with complementary and supplementary angles. Complementary angles are two angles whose measure have a sum of 90 degrees. So a pair of complementary angles from this diagram would actually be angle B and angle A. So if I put them together, I'm just going to add angle A right here. That would be 53 degrees. 53 degrees plus 37 degrees equals 90 degrees. So these would be complementary. Angles add up to 180 degrees. So A and C would be supplementary. If I add A right here, that angle will be 53 degrees. And 127 plus 53 degrees is 180 degrees. So A and C are supplementary. Angles B and C, if you add them together, you get 164 degrees. So those are neither complementary nor supplementary. Adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. Basically, they are two angles that touch each other. You can see an example of adjacent angles, angles 1 and 2, right here. They're right next to each other. They touch. Now, a specific type of adjacent angles is a linear pair. You can see that a linear pair is two adjacent angles that form a straight line. You can see the word line in linear. So when you see linear, think line. Now, linear pairs are supplementary. Check this out. Angle 3 is obtuse. So I'm going to say it's about 135 degrees because obtuse angles are greater than 90 degrees. Now, angle 4 looks like an acute angle because it's less than 90 degrees. So I'm going to say angle 4 is about 45 degrees. So do you see how those two arcs that I drew form a semicircle? A semicircle is a half circle. And a full circle is 360 degrees. So 360 divided by 2 would give us 180 degrees. So a linear pair, those two angles will be supplementary. So let's try this real quick. The problem is asking us to find the complement and supplement of 68 degrees. So if I'm trying to find the complement, I know that complementary angles add up to 90 degrees. So I'll say 90 degrees right here. So to find the complement, all I'm going to do is subtract 68 degrees and I'll get 22 degrees. That is the complement, 22 degrees. Now to find the supplement, I know that supplementary angles are 180 degrees. So to find the supplement, I'm going to subtract 68 degrees from 180 degrees. And that's going to give me 112 degrees. Now number 2 says, determine which pairs of angles are adjacent, linear pairs, complementary, and supplementary. Well, I can look at all these pairs of angles, and they're actually all adjacent. So all of them are adjacent because all the angles are touching. Now, 35 degrees and 55 degrees, they add up to 90 degrees, which makes a right angle. So those are complementary. I'm just going to put C for complementary. 85 degrees and 20 degrees, they're not complementary because they don't add up to 90 degrees, and they're not supplementary because they don't add up to 180. They're also not a linear pair because they don't form a straight line. I throw that out. This one, the same thing is true. This is adjacent, but it's not complementary or supplementary. For this one, we have a straight line. These two angles form a straight line, so they are a linear pair, and linear pairs are supplementary because 130 plus 50 is 180, so this is also supplementary. Now that we have a better understanding of what angles are, let's discuss the angle addition postulate. It states if point S is in the interior of angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. Let's translate that into English. We have two adjacent angles here. So that point S is in the interior of the big angle RQP, or in the postulate it says angle PQR. And then a ray starts at Q and goes through point S, creating two different angles. So basically all this is saying is if you add the angle RQS to the angle PQS, then you add those together and you get the measure of the big angle. So for example, if SQR is 100 degrees and PQS is about, I don't know, let's say 30 degrees, then if you add these together, then the whole big angle PQR is 130 degrees. So this says the measure of angle ABD is 37 degrees and the measure of angle ABC equals 84 degrees. Find the measure of angle DBC. So angle ABD is 37 degrees. So ABD, that's this angle, 37 degrees. The measure of angle ABC is 84 degrees. Now, is that the other smaller angle or is that the large angle, the whole angle? Well, it looks like it's the whole angle, ABC. So this whole angle is 84 degrees. Find is this angle here. So we know that angle ABD plus angle DBC, which is what we're trying to find, equals angle ABC. So I'm going to substitute in here. ABD is 37 degrees plus angle DBC, again, that's what we're trying to find, equals angle ABC. I can substitute for angle ABC. It's 84 degrees. Then I can solve this like an algebra problem. I'm subtract 37 degrees on both sides. That'll cancel. So now I'm left with angle DBC equals, now what's 84 degrees minus 37? Well, it's 47 degrees. So the measure of angle DBC is 47 degrees. Now let's discuss what an angle bisector is. An angle bisector bisects, remember that means cuts in half, an angle into two congruent, meaning equal, angles. So you see right here, I'm going to make that a ray. Usually you'll see that as a ray bisecting that angle, and I'll make those rays as well. But that ray BD bisects that angle. It cuts it into two congruent halves. So let's say that whole angle is 100 degrees. Well, if it cuts 100 degrees in half, then each of these congruent angles is 50 degrees. This problem says that ray BD bisects angle ABC, and the measure of angle ABD is this equation, 6x plus 3 degrees, and the measure of angle DBC equals 8x minus 7 degrees. Find the measure of angle ABD. Okay, so let's start by labeling this diagram that we're given. So ABC is the big angle, angle ABC, and the measure of angle ABD is 6x plus 3. So A to B to D, that's this angle right here, 6x plus 3 degrees. Put that in parentheses because the degree sign applies to the whole expression. Okay. Now the measure of angle DBC is 8x minus 7. Now find the measure of angle ABD. So what I'm trying to find is this angle. It's important to know what you're actually trying to find. So I'm trying to find one of the smaller angles. So here's where I can start. We know that BD bisects the angle. It cuts it in half. So these two smaller angles must be congruent to each other. So that means they're equal. So I can say 6x plus 3 equals 8x minus 7. And then I just solve it like an equation. I'm going to subtract 6x on both sides. And that will get rid of the x term on the left side. And I want to get rid of the constant term, just that number, on the right side. So I'm going to add 7 on both sides. So that'll leave me with just a number on one side, which is 10. 3 plus 7 is 10. And then 8x minus 6x is 2x. So I have the x term on one side, and then just the number on the other. So now I'm going to divide both sides by 2. So 10 divided by 2 is 5. X equals 5. So that's not our final answer. It's really tempting to just box x equals 5 because we're used to solving for x. But it's asking us to find the measure of angle ABD. So I'm going to substitute that in. So I'm going to find measure of angle ABD, that's 6x plus 3. So I'm substituting 5 in for x here. So 6 times 5 plus 3. Well, that's going to give me 33. And we're talking about the angle measure. Remember that degree symbol right here. So our final answer is 33 degrees. So I hope this video was helpful for you. I encourage you to look back through it or look through your slides to help you understand the concepts a little bit more. But come to class with questions and ready to practice what you've learned. Good work today. Thank you, collegiate scholars.